Hello there. It's currently 3 a.m. and I'm at the lodge at Cygnet Cusack Western-super-Mare. I fell asleep today about lunchtime and I was watching season 4 of People Just Do Nothing, which was quite good until I fell asleep and I didn't wake up until about 7:30. When I did wake up, all my devices were offline. I'd been kicked off the Wi-Fi network on my phone and my Alexa. In fact, I can't really bother to show you. It's still on the login mode, and I was in a cold sweat. I'm wearing my baseball cap all day, so you can see this red mark on my head. It's quite embarrassing, really. Anyway, as I've slept for 6 hours already today, I haven't been able to sleep very well. I did take my meds at about 9:15, but one clonazepam tablet, 2 milligram, is quite mild and doesn't really do much. Anyway, keep saying anyway, reiterating and summarising. I was trying to explain, I got a D in maths, but I've got quite a good understanding of physics for one reason or another. And I was trying to explain holonomics to a mate of mine earlier. And it's really complicated to explain. And we were talking before about UFOs and anti-gravity stuff. And my favourite word for this month is ostensibly. Ostensibly, antigravitics doesn't exist. It's not that it's classified. Well, not that it's classified necessarily, but if it does exist, then it is basically. Probably for a lot of different reasons. I raised quite a salient point during our chat, which was that you don't need anti-gravity to travel vast distances if you use holonomic principle and warp drive. In theory, you could make a craft that would be able to travel vast distances, FTL as they call it, faster than light, which some say is impossible, some say it's not, and that's how shit works. So I'm going to put on my ridiculous sunglasses and I'm going to read you a really long bit of research because I'm just so bored I can't think of anything else to do. If you've got any good ideas other than watching TV or smoking this vape, or drinking too much coffee, juice, surfing the internet, on Twitter, Instagram, Facebook, in periods of insomnia, and please do try and contact me. I've just been kicked off the Wi-Fi network again, so if anyone tried to contact me between 2:30 and 3, then do let me know. And yeah, let's have a look at this piece of research which has just been done. Oh, maybe not. It's just completely fucked. But it's disappeared into the ether. Open it again. I'll tell you what I wrote first. Maybe that would be more appropriate. I asked for a detailed explanation of holonomics and how this principle relates to theoretical engineering of a warp drive, including the utilisation of an Einstein-Rosen bridge to cover large distances without the requirement of anti-gravitics. Don't use overcomplicated physics or equations which won't be understood by people who aren't mathematically literate, I wrote, not literature. Anyway, here's that document. It's going to take me a while to work my way through it. I'll put my pretty face in the window so you can see me talking. Get rid of this floating widget UFO thing. So, geometry of motion, a holonomic framework for wormhole-based interstellar propulsion. Part 1, the principle of holonomy, how journeys shape results. At the heart of both classical mechanics and the most advanced theories of modern physics lies a concept as subtle as it is profound, holonomy. In its simplest form, holonomy is the principle that the path of a journey can fundamentally alter the state of the traveller, even if the journey ends precisely where it began. It is the universe's memory of motion, a geometric echo of the route taken. This principle reveals that space, and indeed space-time, is not a passive, featureless stage upon which events unfold, but an active participant whose very structure dictates the outcome of physical processes. To grasp this concept is to take the first step towards understanding how the geometry of the cosmos might be engineered for propulsion. Before delving into the complexities of space-time, it's essential to build an intuitive foundation for holonomy through tangible, everyday examples. Effectively, there's like a differential between flat surface or curvature of space-time, which all goes into Einstein's theory of relativity, which is really why I'm doing this whole thing. But defining holonomy, the path remembers. Holonomy describes the phenomenon where an object or a system, after being guided through a series of transformations that form a closed loop, fails to return to its original configuration. This failure to return is not a flaw or an error, it's a precise quantifiable measure of the intrinsic geometry of the space in which the loop was executed. If a space is perfectly flat and featureless, any property of an object, its orientation, its internal state, will be unchanged after being transported around a closed path. However, if the space possesses curvature or some other interesting topological feature, the journey itself will impart a lasting change. This change is the holonomy. It's really hard to get your head around this, but if you can get your head around it, it makes sense. So this concept extends beyond a single loop. The collection of all possible transformations resulting from all possible closed loops, starting at a single point, forms a sophisticated mathematical structure known as the holonomy group. This group acts as a unique and complete signature of the space's geometry. If one knows the holonomy group, one has a deep understanding of the geometric rules governing that space. In physics, this is of paramount importance, as fundamental forces like electromagnetism and gravity can be described as manifestations of the geometry of abstract spaces. Measuring the holonomy of a test particle as it traverses a loop in a force field, for instance, reveals the properties of that field within the loop. Thus, holonomy is a powerful tool for detecting and quantifying the underlying geometry of the universe, or identifying curvature specifically. The parallel parking analogy. And I tried to explain it earlier. I got a different analogy about an ant on a piece of paper going forwards 10 centimetres, left 10 centimetres, right 10 centimetres, and backwards 10 centimetres, back in the middle. If he had an arrow on his back, he'd be facing the same way. Anyway, this is like parallel parking. It does still explain it, but it's not actually a very good definition, I don't think. Perhaps the most intuitive and powerful real-world example, or perhaps not, in my opinion, of holonomy in action is the parallel parking manoeuvre. Consider the state of a car's steering wheel. A closed loop in this context means starting with the wheels pointing straight, executing a series of manoeuvres, and ending with the wheels once again pointing straight. This typical sequence involves reversing while turning the steering wheel to the right, straightening the wheel and reversing further, driving forward while turning the steering wheel to the left, and then finally straightening the wheel to its original forward-facing position. The steering wheel has completed a cycle. It's returned to its starting state, yet the car has not returned to its starting state. It's undergone a net lateral displacement, moving sideways into the parking space. This net shift is a holonomic effect. A sequence of cyclic operations in the car's control space, the orientation of its wheels, has generated a net translation in its physical space. So this is not merely a clever analogy, it's a mechanical prototype of a sophisticated form of propulsion known as geometric phase propulsion. A propulsion system's fundamental goal is to generate displacement. Conventional systems achieve this by expelling reaction mass, adhering to Newton's third law. The parallel parking manoeuvre, however, achieves displacement without expelling mass in the direction of motion. It operates by applying cyclic control inputs, steering and acceleration, that interact with the constraints of its environment, the friction between the tyres and the road. This reveals a profound principle. Net motion, like getting the car into the space, can be generated by executing a closed loop in a system's internal configuration space. The resulting displacement is the holonomy, often referred to in physics as a geometric phase. This reframes holonomy from a passive descriptor of geometry into an active mechanism for engineered motion. I'll take this glass off now. A concept that will become central to the design of a theoretical space-time drive. The Foucault pendulum, witnessing global curvature locally. In 1851, French physicist Léon Foucault provided a stunning and elegant demonstration of the Earth's rotation using nothing more than a heavy bob suspended by a long wire. The Foucault pendulum is a physical manifestation of holonomy on a planetary scale. When set in motion, the pendulum's plane of oscillation is observed to slowly rotate over the course of a day as it goes round. The rotation is not caused by any local force or torque acting on the pendulum. Don't know what torque is, then Google it. An observer making measurements in the immediate vicinity of the bob would find no physical cause for the precession. The rotation is, in fact, a direct consequence of the pendulum being transported in a circular path, a closed loop, in the curved surface of the Earth. As the Earth rotates, the pendulum's point of suspension is carried along a circle of latitude. The principle of inertia dictates that the pendulum's swing plane attempts to remain fixed in orientation relative to the distant stars. However, because it's constrained to the curved surface of the Earth, its local orientation must adjust. The cumulative effect of these continuous tiny adjustments over a full 24-hour rotation is the net change in swing plane's orientation relative to the ground and the curved Earth. The angular change is the holonomy. Its magnitude is directly proportional to the solid angle closed by the circle of latitude the pendulum traverses. It's a direct measure of the Earth's curvature within that loop. This powerfully illustrates a fundamental duality central to modern physics. A global, non-local property, the curvature of the planet, produces a measurable local effect, which is the precession of the pendulum. A bit like a spirograph, or like, Google, look at the Wikipedia for the experiment if you want. If you can't sleep like me and you're up in the middle of the night, probably work wonders for you. An observer, by performing a purely local experiment and observing its holonomic consequences over time, can deduce the large-scale geometric structure of their world. This is precisely the conceptual foundation of Einstein's general theory of relativity, where the global curvature of space-time dictates the local motion of objects. The thumb on a sphere, visualizing parallel transport. To fully appreciate the mechanism behind holonomy, one must understand the concept of parallel transport. On a flat surface, like a sheet of paper, parallel transport is simple. A vector, an arrow, is moved from one point to another without changing its direction. So if this vector is moved around any closed loop on paper, it will point in exactly the same direction when it returns to its starting point. This is because the geometry of the paper is Euclidean or flat, and the holonomy is trivial. So there might be like tiny fluctuations in the flatness, but basically it's a flat bit of paper. On a curved surface, situation is fundamentally different. The very definition of keeping a vector parallel becomes path dependent. This can be visualized with a simple exercise. Try this at home. Extend your arm straight out in front of you, not like Adolf Hitler, with your thumb pointing directly upwards. Your hand is now at a point on an imaginary sphere centered at your shoulder. I'm not going to do it because you can't see me in the window, but keeping your arm straight and parallel to the floor, sweep it 90 degrees to your right. At each infinitesimal step of this motion, you keep your thumb orientated parallel to its previous direction. It remains pointing upwards. Now, keeping your arm to your right, raise it 90 degrees until it points directly at the ceiling. Again, you maintain the thumb's orientation locally parallel, so it is now pointing forward parallel to the floor. Finally, bring your arm back down to its original starting point in front of you. Upon returning to the starting point, you will notice that your thumb is no longer pointing upwards. It's pointing to your left. It's rotated by 90 degrees. This rotation is the holonomy of the path you traced on the sphere. At no point did you actively twist your wrist. The change in the thumb's orientation is an unavoidable consequence of parallel transporting it around a loop in a curved space. The final orientation is a direct measurement of the curvature enclosed by the loop. This example reveals that on a curved manifold, local rules of parallelism do not guarantee a global return to the original state. The space itself encodes a set of instructions for how vectors must transform as they move, and holonomy is the language of those instructions. Part 2. Holonomy and the fabric of space-time. The intuitive principles of holonomy, illustrated by parked cars and swinging pendulums, are not mere mathematical curiosities. They are the fundamental language used by Albert Einstein's theory of general relativity to describe the force of gravity. In this framework, space-time is not a static backdrop for physical events, but a dynamic four-dimensional manifold whose geometric properties are determined by the distribution of mass and energy within it. The concepts of curvature, parallel transport, and holonomy are elevated from abstract tools to the literal physical descriptors of the gravitational field itself. General relativity as a geometric theory. So Einstein's revolutionary insight was to reimagine gravity not as a force that propagates through space, but as an intrinsic property of space-time itself. The famous dictum of physicist John Wheeler summarizes this relationship. Space-time tells matter how to move, matter tells space-time how to curve. Very good statement. Great quote, that one. In this view, planets orbit the sun not because they're being pulled by a mysterious force, but because they're following the straightest possible path, called geodesics, through a region of space-time that's been curved by the sun's immense mass. So the sun's got loads of mass and density, so it curves space-time. A bit like if you see those diagrams where it looks like you've sort of got a bed sheet with a bowling ball in the middle of it, and it sort of goes like that. This geometrization of gravity means that the tools of different geometry directly applicable to describing the physical universe. The presence of a massive object warps the geometry of space-time around it, and this warping is what we perceive as gravity. Consequently, the holonomy of space-time becomes a direct measure of the gravitational field's strength and character. So space-time curvature as holonomy. The connection between holonomy and gravity is a direct and absolute. The curvature of space-time is holonomy. In a region of flat, empty space-time, far from any significant sources of mass or energy, known as Minkowski space, the geometry is trivial. A vector, such as the spin axis of a gyroscope, that is parallel transported around any closed loop in this flat space-time, so far away from gravity, will return to its starting point with its orientation completely unchanged. The holonomy group of Minkowski space is trivial, reflecting the absence of gravity. Now, consider the same gyroscope in orbit around the Earth. The Earth's mass curves the space-time in its vicinity. If the gyroscope completes one full orbit, a closed loop in space-time, its spin axis will not point in the same direction as it did at the start of the orbit, so it'll be slightly tilted. This phenomenon, known as geodesic precession, or the sitter effect, has been experimentally verified with extreme precision by missions like Gravity Probe B. This precision is a direct, measurable holonomic effect. It is the accumulated change resulting from a parallel transport of a vector around a loop in curved space-time. This relationship is formalized by the Ambrose-Singer holonomy theorem, which states that the algebra of the holonomy group at a point is generated by the space-time curvature tensor at that point and all points reachable from it. In simple terms, complete knowledge of the local curvature everywhere within a region allows one to calculate and predict all possible holonomic effects for any loop within that region. So holonomy and curvature are two sides of the same coin in a way. One describes the local bending of space-time, while the other describes the cumulative non-local consequences of that bending. Bit of a headfuck. Read it when I put it in the description. Holonomy as a physical observable. This deep connection elevates holonomy from a mere geometric effect to a fundamental and observable property of the gravitational field. In fact, research into the structure of general relativity has shown that in a vacuum, or in the presence of a cosmological constant which describes the accelerated expansion of the universe, the holonomy group associated with a specific formulation of gravity, the chiral spin connection, is a conserved quantity. This means that the the geometric fingerprint of a region of empty space-time is time independent. And what that means is that it does not change as time evolves. This conservation of holonomy is like a profound statement about the underlying stability of space-time geometry in the absence of matter. However, the same research reveals a critical exception. Once matter is coupled to gravity, the conservation of holonomy is lost. This is the crucial physical lever that makes a holonomic propulsion system theoretically conceivable. A propulsion system must, by definition, induce a change in its state of motion, which requires breaking some form of stasis or conservation. The fact that the local holonomy of space-time can be altered by the presence of motion and matter-energy fields provides a mechanism for such a system. Instead of creating a static warp bubble with a fixed geometry, as in the Alcubierre model, a holonomic drive would function by actively modulating the local holonomy. So this modulation is performed in a cyclical and non-reciprocal manner. If performed in a cyclical and non-reciprocal manner, could produce a net propulsive force. In theory, the non-conservation of holonomy in the presence of matter is not a theoretical limitation. It's the essential feature that permits a dynamic interaction with the geometric structure of space-time. It provides a way to push off of the fabric of reality itself. This perspective also forces a re-evaluation of what empty space truly is. Holonomy demonstrates that the vacuum is not a featureless void. Even in the absence of matter, space-time possesses a latent geometric structure, a field of instructions that dictates how physical quantities must transform when moved. It is a structured, deformable, and ultimately engineerable medium. This understanding is the prerequisite for accepting the premise of a drive that moves not through space, but by interacting with it. Part 3. Conventional paradigms of faster-than-light travel and their limitations. Before constructing a new model for interstellar travel, it's necessary to examine the existing theoretical paradigms and understand their profound limitations. So this is without anti-gravity, assuming anti-gravity doesn't exist, but this technology does. Particularly the context of the constraints specified. So the two most prominent concepts for faster-than-light travel derived from general relativity are the Alcubierre warp drive and the Morris-Thorne traversable wormhole. While mathematically valid solutions to Einstein's field equations, both rely on a physical requirement that's currently considered unattainable, and which this report seeks to circumvent, which is the use of exotic matter to generate anti-gravitational effects. So the Alcubierre warp drive pushing with negative gravity. Back in 1994, Miguel Alcubierre proposed a space-time metric that allows for apparent faster-than-light travel without violating local relativistic laws. Alcubierre drive does not propel a spacecraft through space at superluminal speeds. Instead, it manipulates space-time itself, creating a warp bubble of flat, undisturbed space-time around the vessel. This bubble is then moved by contracting space-time in front of it and expanding space-time behind it. A passenger inside the bubble would feel no acceleration and would locally always be moving slower than light. However, the bubble itself could be swept along at an arbitrarily high velocity relative to an outside observer. Again, a head fuck, but it does make sense if you just get your head around it. The critical issue arises when one asks what kind of matter or energy is required to create such specific space-time curvature. Loads of mass, basically, gravity. According to the Einstein field equations, this geometry necessitates a distribution of matter with a negative energy density. This hypothetical exotic matter would possess bizarre properties, basically superfluids and stuff like that, including a repulsive gravitational field. It's this antigravitic property that's needed to generate the expansion of space-time behind the bubble. Early calculations suggested that the amount of negative energy required would be equivalent to the mass of Jupiter, though subsequent theoretical refinements by researchers like Harold Sonny White proposed that shaping the warp bubble into a torus could drastically reduce this requirement to a few metric tons. Despite these optimizations, the fundamental need for a substance that generates anti-gravity remains, placing the concept of this theory firmly in the realm of speculative physics. But the Einstein-Rosen bridge is also a non-traversable shortcut. So in theory, not viable, but it changes in a bit, this bit of research. So the first scientifically described wormhole emerged from a work of Albert Einstein and Nathan Rosen in 1935. Interesting time for them to be doing that research. The Einstein-Rosen bridge is a vacuum solution to the field equation representing a geometric connection, or throat, between two distinct regions of space-time, or even two separate universes. It can be visualized as the geometric extension of a black hole, connecting it to a white hole in another region. While it presents as tantalizingly direct shortcut across cosmic distances, the original Einstein-Rosen bridge has a fatal flaw. Oh, wait there. I think someone's coming. No? So the flaw in the Einstein-Rosen bridge is that it's non-traversable. Creaky floorboards. I always think they're coming to my fucking door and I have to pause the recording. I think they are. Right, so anyway, there's a fatal flaw. Not literally fatal. Well, it would be fatal if you went into it. It's non-traversable. In 1962, physicists John Wheeler and Robert Fuller demonstrated that the throat of this type of wormhole is dynamically unstable. It pinches off into a singularity so rapidly that not even a beam of light, the fastest thing in the universe, has enough time to pass through it. Any object or observer attempting to transit... Sorry, a bit disjointed here. I keep thinking there's people coming to my door, so I can hear them on the fucking creaky floorboards. And the guys upstairs, they're awake. Whenever I wake up, they're just up all night. Whenever I wake up in the middle of the night, there's always talking, laughing on the top floor. But I won't bother any of those guys. So it pinches off into a singularity so rapidly that not even a beam of light, the fastest thing in the universe, has enough time to pass through it. So you could open a wormhole, but it would close before you could get into it. Any object or observer attempting the transit would be caught in the collapsing throat and destroyed. Therefore, in its original form, the Einstein-Rosen bridge is a fascinating geometric object, but an impractical means of transportation. Then you've got the Morris-Thorne wormhole propping the door open. The problem of wormhole instability was addressed in the 1980s by Kip Thorne and his student Michael Morris, who set out to determine the physical requirements for a traversable wormhole. Their solution was to find a way to counteract the wormhole's tendency to collapse. They calculated that the throat could be held open indefinitely, but only if it were threaded with a substance that exerts an enormous negative pressure, in effect an anti-gravitational force. Once again, the solution relies on the existence of exotic matter with negative energy density, which, we're going to assume for the purposes of this non-classified presentation that doesn't exist. This material will be required to line the throat of the wormhole, providing the repulsive gravitational pressure needed to prop it open against its own gravitational self-attraction. Just as with the Accu-Bear drive, the creation of a stable, traversable wormhole appears to be fundamentally dependent on the ability to source and control matter with antigravitic properties, a direct violation of the core constraint of this investigation. The fundamental limitation shared by both the Alcubierre drive and the Morris-Thorne wormhole is their reliance on static geometric solutions. Both models begin by postulating a desirable final space-time geometry, a warp bubble or a stable open wormhole, and then use the Einstein field equations to calculate the matter-energy distribution required to sustain that fixed structure. So in both cases, the answer is a static field of negative energy. This approach is akin to designing a fantastical bridge and then discovering that the only material strong enough to build it is unobtainium. This reveals a deep conceptual bottleneck in the conventional faster-than-light theory. The focus on creating stable static structures in space-time. The alternative, which a holonomic drive embodies, is is to reframe the problem as a dynamic, continuous process. Instead of building a static bridge across a river, your proposed system will provide a method to actively swim across it. This shifts the engineering challenge from one of exotic materials to one of dynamic energy application. So another one of these, if you watch I just can't be bothered to read these tables. They're really annoying. Fuck it, I'll read the table. Look, right, so functions, you've got one column, it's the feature metric, the Alcubierre warp drive, the Morris-Thorne traversable wormhole, and the proposed holonomic wormhole system, which is the key factor. So the fundamental principle, static deformation of space-time, contraction, expansion, creating a moving bubble. With the Alcubierre warp drive, the propulsion mechanism is space-time bubble that moves, carrying this flat space interior with it. Energy requirement is massive quantities of negative energy density, something the size of Jupiter. The role of antigravitics would be essential and so therefore impossible for the purposes of this report. The negative energy density creates the required repulsive gravitational effect. Causality concerns potential for creating time-like loops through Alcubierre's specific metric avoids some paradoxes. Key challenge would be sourcing and manipulating stable exotic matter with negative mass energy, which, if you believe in Wikipedia, it doesn't exist. Some people think it does, though. Don't ask me. Static geometric shortcut through space-time held open against collapse. So this is the Morris-Thorne traversable wormhole, the one that's been stabilised. So there's no propulsion. Oh, you have to look at the fucking... Right, propulsion mechanism, no propulsion. It provides a static traversable path. Next row, energy requirement for the Morris-Thorne one. It's massive quantities of negative energy density to stabilise the throat. That means, it's a bit of an unromantic way of describing the wormhole. The role of antigravitics in this instance is essential. The negative energy provides the antigravitic pressure to prop the throat open, which is not possible. The next row is causality concerns. Can be engineered to be a time machine, creating significant paradoxes. Fuck that off completely. Last bit, sourcing, manipulating stable exotic matter with negative mass energy. So that's the key challenge. Again, sourcing with same as the other one. You need antigravitics and exotic matter, helium or hydrogen superfluids, or helium-3, like it says in that fucking movie or whatever. Anyway, right, we're going to do a lot of left and right swiping now. But the proposed holonomic wormhole system, dynamic cyclical deformation of space-time, enabling swimming and transient wormhole stabilisation, is the fundamental principle. The propulsion mechanism of the holonomic wormhole system would be geometric phase propulsion, so non-reciprocal space-time deformations that create a net displacement. This row, energy requirement of the holonomic one, immense quantities of positive energy to power the dynamic deformation cycle, to create that curvature. The role of antigravitics in holonomics would not be required, so stabilisation is achieved dynamically through high-frequency geometric oscillations. Pretty cool. So you don't need to have impossible technology. Causality concerns, potentially mitigated by the transient, on-demand nature of the wormhole. And the last row, which you can explore at your leisure with the link to this piece of research, is the key challenge would be achieving near total energy to geometry conversion efficiency and a very precise high frequency control of that space-time curvature that you're kind of bending to make sort of like go like that. So you can just go whoop, whoop, and you go through, and then you out the other side. Anyway, moving swiftly on, part 4, propulsion as a geometric phase swimming through space-time. Putting my shades back on for this bit. The limitation of static faster than light models, plural, necessitate a paradigm shift. Instead of engineering a fixed geometric structure with exotic materials, a more plausible, albeit still deeply theoretical approach is to engineer a dynamic process that uses conventional energy to interact with the geometry of space-time. This leads to the concept of propulsion as a geometric phase, a direct physical application of holonomy. The core idea is to make a vessel swim through space-time by executing a sequence of non-reciprocal shape changes in its local gravitational field. So the scallop theorem and non-reciprocal motion is a shit metaphor, this, but there we are, if you like scallops. The foundational principle for this type of motion comes from fluid dynamics. In the 1970s, physicist Edward Purcell formulated what is now known as the scallop theorem. It addresses locomotion in environments dominated by viscosity. That's very relevant. Superfluids have interesting viscosity, but they're not used in antigravity. It's just a theory. So, yeah, environments dominated by viscosity, such as microorganisms swimming in water, where inertia is negligible, a low Reynolds number regime. Purcell showed that a simple reciprocal motion, one that's identical to its time reverse counterpart, like a scallop opening and closing its shell, produces zero net displacement. So the distance gained during the closing stroke is exactly cancelled by the distance lost during the opening stroke. To achieve net propulsion, which, has nothing to do with fucking scallops, in such an environment, an organism must execute a sequence of motions that is non-reciprocal, meaning the sequence looks different when run forwards versus backwards in time. A bacterium's corkscrewing flagellum is a classic example of such a non-reciprocal stroke. In the context of propellantless propulsion, space-time can be thought of as the ultimate viscous medium. One cannot simply push on it and then pull back symmetrically and expect to go anywhere. The net effect would be zero. So to achieve propulsion by interacting with space-time geometry, a system must perform a non-reciprocal cycle of actions, like a twisty thing, like these flat lights twisting round like curly whirlies. Well, not sweet curly whirly, like girls' curly hair. Geometric phase propulsion in nature and robotics. This principle is not merely theoretical, it's widely employed in the biological world and has been successfully replicated in robotics. Animals like snakes, eels and nematode worms propel themselves by propagating waves of the body curvature from head to tail. This travelling wave is a fundamentally non-reciprocal cycle of shape changes. Each segment of the body follows the motion of the segment ahead of it, but with a time delay, creating a continuous directional pattern that pushes against the environment to generate forward motion. More profoundly, this principle extends to motion generated purely by the curvature of the space an object inhabits. So recent experiments have demonstrated that a robot confined to a spherical surface can achieve net displacement solely through internal shape changes without pushing against any external medium. If you don't know what that means, then please just Google it. By cyclically moving internal masses along curved tracks, the robot performs a non-reciprocal sequence of configurations. Because the translations on a curved surface do not commute, so moving north then east is not the same as moving east and north. This closed cycle of shape changes results in a net shift in the robot's position on the sphere. This displacement is a pure geometric phase, a holonomic effect resulting directly from the interaction between the robot's changing shape and the curvature of the space it occupies. In a flat space, the same sequence of motions would produce zero net displacement. This confirms that it's possible to generate motion by swimming through a curved geometry. The holonomic drive, a space-time swimmer. This leads to the central concept of this report, the holonomic drive. This theoretical propulsion system would not generate a static warp field. Instead, it would function as a space-time swimmer, inducing rapid, cyclical, and fundamentally asymmetric, non-reciprocal deformations in the local space-time geometry around the spacecraft. So, conceptual mechanism can be envisioned as followed. So, the drive rapidly generates a localized, intense gravitational potential well immediately in front of the spacecraft. So, it makes the gravity bend space-time in front of the spacecraft itself. This would require a momentary extreme concentration of positive energy The spacecraft begins to fall into this self-generated dimple in space-time. Simultaneously, but on a slower timescale, the drive generates a gravitational potential hill behind the craft. So before the craft falls far, the drive rapidly dissipates the potential well in front. Finally, the drive slowly dissipates the potential hill behind it. This 4-stroke cycle, quick pull, slow push, quick release, slow release, is non-reciprocal. It's a really difficult one to get your head around that, but the sequence is not symmetric in time. So by repeating the cycle at an extremely high frequency, the spacecraft would be continually pulled forward by its own transient manipulations of space-time. The net movement of the vessel would be a holonomic effect. It has completed a closed loop in its geometric configuration of space, the shape of the local space-time it generates, resulting in a net displacement of or in physical space. Crucially, this model fundamentally alters the energy problem. The Alcubierre drive requires a vast amount of negative energy, as opposed to positive energy, to be present statically to maintain the warp bubble's structure, posing a material science problem that may be physically impossible. The holonomic drive, by contrast, consumes immense but positive energy dynamically to perform the deformation cycle. The energy used to do work on the space-time metric. This shifts the challenge from sourcing impossible exotic matter, or classified exotic matter, to the domains of extreme energy generation and precise high-frequency control of energy fields. While still a colossal engineering challenge, it is conceptually grounded in known physics, unlike antigravitics. This system does not require antigravitics because its operation is not based on static repulsion. It's based on a dynamic asymmetric push-pull against the local geometry, where the non-reciprocal nature of the cycle prevents the pull from cancelling the push. Furthermore, at subliminal speeds, such a drive would be inherently relativistic and causality compliant, as the ship is always moving slower than light within its immediate local frame, and no signals are required to propagate faster than light to coordinate the cycle. Part 5. A holonomic wormhole transit system. Now this is where it gets good. So the principle of holonomic propulsion provides a mechanism for efficient propellantless travel within space-time. However, to achieve the goal of superluminal travel, that means faster than the speed of light, across interstellar distances, this engine must be integrated with a method for traversing space-time shortcuts. This final speculative synthesis combines the dynamic capabilities of the holonomic drive with the geometric structure of the Einstein-Rosen bridge to create a theoretical faster than light transit system that operates without recourse to static antigravitics. So the dynamic stabilization of an Einstein-Rosen bridge, the primary obstacle to using an Einstein-Rosen bridge for travel is its violent instability. The throat of the wormhole pinches off into a singularity almost instantaneously. The conventional solution proposed by Morris and Thorne is to use a static scaffolding of exotic matter to generate anti-gravitational pressure and hold the throat open. The holonomic approach offers a radically different solution: dynamic stabilization. The tendency of the wormhole throat to collapse can be modelled as an extremely high frequency oscillation or vibration, rather than propping it open with a static force. The holonomic drive, with its inherent ability to create precise high frequency localized space-time oscillations, could be uniquely suited to counteract this collapse. So the drive could be tuned to the resonant frequency of the instability. At the precise moment the throat begins to pinch inwards, the drive would execute a powerful outward push phase of its cycle, forcing the geometry back open. This would be followed by a relaxation phase, ready for a net inward fluctuation, a bit like taking a dump but not having a prolapse. This process is analogous to acoustic levitation, where an object is suspended in midair not by an inherent anti-gravity property, but by the continuous dynamic pressure of focused sound waves. There's loads of dog shit on the internet about building the pyramids using sound waves. Google that if you've had a spliff and you're Ancient Alien series is finished. So the dynamic pressure of focused sound waves, which is the force counteracting the wormhole's collapse, is not a static property of an exotic material, but a result of dynamic, time-varying application of immersive positive energy to the local space-time geometry. This active, energy-consuming stabilization process replaces the need for antigravitics entirely, thereby satisfying the core constraint of the user's query. Theoretical work on perturbing a non-holonomic background of space to generate a directed momentum flow provides a parallel framework for understanding how forces can arise from such dynamic geometric effects. The journey profile: create, traverse, exit. A conceptual interstellar journey using this holonomic wormhole transit system would proceed in 3 distinct phases. First one would be initiation. Spacecraft powered by a sufficiently advanced energy source, perhaps total mass to energy conversion, travels to a designated departure point in space using its holonomic drive in its subliminal swimming mode. Once in position, it reconfigures the drive's operation. Instead of producing net thrust, the drive focuses its entire energy output into generating the specific high frequency, high amplitude space-time oscillations required to momentarily tear open a macroscopic Einstein-Rosen bridge and dynamically stabilize its throat. This act of space-time metric engineering would represent a direct conversion of energy into a geometric structure. Transit: with the throat held open by the continuous rapid pulses of the drive, spacecraft would then pass through it. The interior of an Einstein-Rosen bridge is theorized to be a region of regular, non-singular space-time that connects to an entirely different, distant location. The journey through the throat itself would be effectively instantaneous from the perspective of an outside observer. Exit: upon emerging at the destination, the holonomic drive would continue to stabilize the exit aperture just long enough for the vessel to clear the throat, get out of the wormhole. Once the spacecraft has fully emerged, the drive would cease its stabilization cycle. No longer sustained by the dynamic application of energy, the wormhole would immediately pinch off and vanish, leaving no trace of the geometric tunnel. Circumventing the anti-gravity requirement. Very important. If you want to build yourself a warp drive in a spaceship, I'll get my money in a few weeks, my UC, so I'll chip in if everyone's up for it. But this model successfully circumvents the need for antigravitics and the associated exotic matter. The key distinction lies in the nature of the stabilizing force. In the Morris-Thorne model, the force is a static, repulsive pressure that is an intrinsic property of the exotic matter itself. In the holonomic model, the stabilizing force is dynamic and transient. It is the result of a continuous active process of pushing space-time outwards, powered by a conventional, albeit unimaginably powerful energy source. You might need, hydrogen fuel cells or cold fusion, which hydrogen fuel cells aren't classified, but cold fusion sadly is. The system does not require any material wealth with inherent anti-gravitational properties, which is good. But you do need a lot of energy, and I don't know how you're going to get that. This approach creates a single-use or point-to-point transit system. Unlike the permanent stargates of science fiction, the wormhole created by this method is a transient phenomenon, existing only for the brief moment it's being actively generated and sustained by the ship's drive. As soon as the ship passes through and the drive is no longer present at the throat, the connection collapses. So this has a significant and beneficial consequence. It may avoid many of the paradoxes associated with time travel that plague theories of permanent two-way wormholes. The connection is a dedicated on-demand tunnel for a single transit, not a public highway through space-time. The entire process represents the ultimate application of Einstein's famous equation, the only one that they've put in here, which we all know. The ship must carry an energy source capable of being converted directly into a macroscopic geometric structure, the wormhole throat. I reckon they should call it a flange, or like a vag, the wormhole vag, the orifice. The primary challenge is thus reframed. It is no longer a search for new physics in the form of exotic matter, but rather the ultimate engineering problem, achieving near perfect efficiency in the conservation of energy into a controlled dynamic space-time geometry. So it's not easy. Concluding analysis, a new horizon for theoretical propulsion. The framework presented in this report outlines a speculative but physically grounded pathway towards interstellar travel that adheres to the specified constraint of avoiding antigravitics. By synthesizing the geometric principle of holonomy with the dynamic nature of space-time as described by general relativity, it is possible to construct a new class of propulsion theory. This approach recasts the problem of faster-than-light travel from one of exotic materials to one of extreme dynamic energy manipulation. Haven't you got the power, Captain? Summary of the holonomic propulsion framework. So the core argument of this analysis can be summarised in a logical progression. Part 1, holonomy is a real physical effect resulting from the curvature of space. It demonstrates that executing a closed loop of operations in a system's internal configuration can lead to net displacement in its physical position, what they call a geometric phase. 2, space-time is a curved dynamic medium whose geometry is synonymous with the gravitational field. Its local holonomy can be altered by the presence of motion of matter and energy. 3, a holonomic drive could function as a space-time swimmer, applying immense positive energy in a rapid, non-reciprocal cycles to create asymmetric deformations in the local space-time geometry, thereby generating propellantless thrust. This drive could then be used to dynamically stabilize the throat of an otherwise unstable Einstein-Rosen bridge, pulsing energy into the geometry to counteract its tendency to collapse. The result is a transient point-to-point faster-than-light transit system that creates a wormhole on demand, allows for instantaneous passage, and then allows the connection to vanish. This system achieves its goal without relying on the static, repulsive gravitational fields of negative energy density. Immense challenges and future directions. It must be stated unequivocally that this concept, while theoretically coherent, resides at the farthest frontier of speculative science. The engineering and physics challenges are of a scale that is difficult to comprehend. The primary obstacles include energy generation and storage. The energy densities required to create a macroscopic deformation of space-time, let alone a wormhole, are astronomical. This would likely necessitate technologies far beyond our current understanding, or what we're allowed to know about, such as the complete and efficient conversion of mass into usable energy and the ability to store and discharge this energy with near perfect control. Then you got geometric control, the ability to shape and modulate energy fields with the precision, frequency and intensity needed to create a specific time-varying space-time curvatures is a challenge of unimaginable complexity. It implies a mastery over the fundamental forces of nature that's presently the domain of science fiction. You would just need like something to do with Nikola Tesla, probably, or like perpetual motion, one of the two. Or some other stuff. I mean, I don't know. Anyway, quantum gravity is another bit. Oh, someone's coming up the stairs. I'm going to have to pause it. Yeah, 3:57. Just did my obs. The nurse. Lovely. Anyway, general relativity, upon which this model is based, is an incomplete theory. So it doesn't account for quantum mechanics. Manipulating space-time at the scales and energies discussed would inevitably involve quantum effects. A complete predictive understanding of such a system would require a unified theory of quantum gravity, which remains something we can't work out, the single greatest unsolved problem in fundamental physics. So that would make it difficult, even if I do chip in half my UC money. A new class of propulsion theory. Despite these daunting challenges, value of this conceptual framework lies in the new direction it provides for theoretical exploration. It represents a shift away from the static geometric paradigm that's dominated faster than light research since the 1990s. The models of Alcubierre and Maurice Thorne are fundamentally about finding a substance with the right static properties to create desired space-time structure. The holonomic model belongs to a new class of dynamic geometric propulsion theories. This new class shifts the focus from a search for exotic materials to an investigation into dynamics of energy space-time interaction. It asks not what must we find, but what must we do? The central questions become, how can energy be converted into geometry with maximum efficiency? What are the resonant frequencies of space-time itself? How can non-reciprocal cycles of energy application be optimized to produce the greatest propulsive effect? While the engineering of a functional holonomic drive remains a distant dream, the theory itself offers a rich and compelling new avenue for thought. It suggests that the secret to traversing the cosmos may not lie in discovering strange new particles, but in learning to perform an intricate and powerful dance with the very fabric of space-time itself. It's 4 a.m. now. I'm going to have some hot chocolate, go to bed. I've been in bed, but I can't sleep because I slept too long earlier on. And now I've made an hour-long video. I might put the lights back onto weird mode. There we go. Now they're going to like change colour. Amazing. Yeah, fuck knows what to say at the end of that video. It was just a, just a kind of flagellation of my brain and the internet, because I'm so bored and I'm so tired and I'm so lonely and I'm quite sad as well. But I hope that video has cheered you up. If you want to build a spaceship, let me know, and cheers. Bye.